want to still look at the PET model. It's also quite interesting, especially because I haven't looked at it in detail. Let's do that. So this is a different model. And it said here, as you remember, it said, while the UTCI is designed to be valid in all climates and seasons, it assumes that human subjects are walking and that they naturally adapt their clothing with the outdoor temperature. For outdoor simulations that do not fit this criteria, the Physiological Equivalent Temperature, PET model is recommended. And that's what we try to look at. So we have similar inputs. So we have the dry pulp temperature. We also have the mean radiant temperature. We can put this in here. Relative humidity here. Air speed. We can take the wind speed. The air pressure. So it has more barometric pressure. It's here. And we need a run button as well. It calculates significantly longer. Let's compare. I will just kick out one of these. So let's not use that. This was just the simple version. Now we're comparing this one, the PET to the UTCI. So PET on the top, and it looks quite different. What else can we put in here? The mat rate. That's interesting because it can help us to estimate what the individual person will feel roughly, of course, when they're working, sitting, standing. That's quite interesting. So, okay, the mat rate. Let's check what PET, what it does. Okay, the PET uses the Munich energy balance model, which is arguably the most detailed free-node human energy balance model in common use today. It can account for various physiological features of the human subject, including age, sex, height, and body mass, making it one of the only models that is suitable for forecasting the thermal experience of a specific individual. This also makes it one of the better models for estimating core body temperature and whether a given set of conditions is likely to include hypothermia or hyperthermia in a specific individual. Okay, wow. What does that mean? So difficult text. Anyway, the mat rate. Okay, what's the mat rate? The mat rate is the metabolic rate. Let's try it. Let's just try it out. Okay, the data collection or individual value of the metabolic rate in MET. Note that the original PET model requires that the activity of the human subject be accounted for as additional watts above the basal metabolism, which is often difficult to estimate. In order to accept an input in MET, it is assumed that 1 MET refers to the resting metabolic rate, and this is 1.7 times the male basal metabolic rate, or 1.22 times the female basal metabolic rate. Default is set to 2.4 MET for walking. Typical values include the following. For me, it's interesting because this is a space for women. It's going to be the women-owned space. Doesn't mean that there won't be males working, but in the first instance is for women. So that's why I try to understand how that mat rate works. But for now, we can just assume that we can try different rates here. Okay, again, what is the mat rate? The mat rate is, so this input here is about the metabolic rate of people in different modes, like sitting, resting, standing, walking, and so on. I don't know yet how that affects the output, but we can just try. So let's assume people on the site, they walk quite a lot. They will walk around. They work here. This is a farm, so they will just walk around and do things. So, and they might sit also in some areas. But we can refine that as we want, depending on the activity. It's actually cool because then we can look at the program later. And let's just put here, I don't know, 1.2. This is for, the default is set to 2.4. This is for walking. So this is already set. Actually, we don't need to set anything here, except we want to change that. So let's just put here 1 to 5. Let's say 1 to 5. Now it calculates quite a lot here, quite long. It definitely calculates more than the UTCI model. The thing is with the walking is it's maybe not that accurate because it's on the farm you're more standing. Let's keep maybe 1.2 as standing around or like standing. Because I mean, if you work there hard, then of course you're gonna feel hot. But let's keep that in mind. So I need to kind of research a bit on how that actually works. Clothing, 3-piece suit, no. Shorts and t-shirts, much more likely, let's say. Again, it's calculating quite a lot. And let's look at the chart. It's quite different. It's really different. I'm wondering if that has something to do with the barometric pressure. And again, there's more. We can actually input more stuff. Optional comfort parameters from the Ladybug PET body parameters. Also, by the way, we have that here as well. Somewhere we have. No, actually here not. Here we put everything we can, except for the fractional body exposure and the sky exposure. We haven't done that yet. We'll do that when we get there. But there's the solar body parameters. So there is there's a default value in here. I think it becomes a bit too esoteric. But yeah, let's try the PET parameters. Opala, we're already here. Where can we find this? The Ladybug PET body parameters. Oh yes, that's what I need. This is exactly what I need. So we can compare male and female and age. So okay, let's do this. Just copying the whole thing. Let's just get another point here. Just copy this. I just take this and so we call this women and men. Okay. Yeah. So we don't get confused. This one is this one. This is the male. This is female. Okay. Great. And now I can put this here and here. Becomes a real crazy salad here. Just need to clean up here a bit. One means female, so this is women, and this is man. Okay. Is there any change? Is the question. Does it really make a difference? Put this a bit closer. I think I'll take off the legend parameters for a while. It just doesn't. It does. Yeah, let's keep it like this. So this is also again quite a different chart because it's actually crazy how different this is. If you look at this is just the temperature. This is the universal thermal climate index. It's completely different. It's like how can you actually trust person standing? Okay, the person standing we have both the same. Now, okay, let's say the people. Now I would need to know the average height. So here says ChatGPT told me that the average height for female in Rwanda is 1 meter and centimeter. Okay, 2. Okay, 1 meter 70, 1 meter 57, and for men is 1.7. 44.29, and here we have 44.15. Men, women. Women experience the temperature cooler. Okay, body mass. Yeah, let's keep that. I mean, you can play with that if you want to measure, if you want to estimate yourself and you have the data. Perfect. Men probably have more body mass. Just leave this here. I would say body mass index. Body mass probably different for men here. Let's say 80 kilos probably. And then we have posture. You can either sitting, standing. That's already done with the met rate. I don't think it will have any effect if we change that. And then the humidity Boolean to note whether the human subject is acclimated to a humid tropical climate or is acclimated to a temperated climate. That's true. the people there are more acclimated to a tropical climate, I would say. Let's put this through here. Doesn't change much. But yeah, at least we try everything and have something to compare. It's quite interesting. It feels like the women cope better with higher temperatures. I mean, this for me is the biggest shock. The difference here is this is also we have some weird data coming up with -12, whereas here we actually don't have that. So this to me, the PT model seems much more accurate. Feels much more accurate than the Universal Thermoclimate Index. And I'm wondering if that has something to do with, I mean, for sure how it's calculated. I wonder what happens if I change this to, let's say, 2.5. Yeah, okay. So it means higher metabolism means hot feels even hotter. That makes sense. Okay, let's go back here. So probably in some doing some of the years better you don't work in the afternoon outside because it just feels really, really hot. Now the last thing I want to try here now today is I'll just add here the solar body parameters that we haven't really looked at. Solar body parameters, solar. Okay, so we can add this in here. I'm wondering if I put it wrong, something wrong. Horizontal infrared radiation, diffuse horizontal radiation, direct normal radiation, surface temperature. That might be an issue. Location is here. If the elevation maybe has something to do with this big change, because here you don't, in the PET model, we don't use the location. Could have an influence, but it feels a bit strange. The -12 degrees doesn't feel right at all. Okay, here I can also use different body modes: standing, seated, supine. What's the supine? Lying on the ground. You could have just said lying on the ground, standing. Let's put standing. So this one has something to do with the angle of the sun. I'll just keep it as it is. Body AZ. What's that? A number between 0 and 360, representing the direct direction that the human is facing in degrees. Yeah, this is also a bit. The person working here will face all sides at some point. Absorptivity. A number between 0 and 1, representing the average shortwave absorptivity of the body. It's basically the color of the clothing and the skin. Okay, and let's keep that as it is. Average is here 0.7 for average brown skin and medium clothing. It's hard to tell what kind of clothes, more khaki colors probably, less black. But I think it's fine. A number between 0 and 1 representing the average long wave emissivity of the body. Default is 0.1, which is almost always the case except in rare situations of wearing metallic clothing. All right, I think that's pretty intense. So we learned two models, two outdoor comfort models, both representing the feels like temperature, whereas the physiological equivalent temperature seems to be way more accurate than the Universal Thermoclimate Index. I think in future I will refer more to this, especially if I want to understand a bit about difference between male, female. Age actually would be interesting. Let's say age here is, the default is 36. That's probably the right age. That's the age group I think will be actually on site. So that's I will not change that. But of course I'm interested in how much that would affect. So if I, let's say here, that's super interesting. I don't know. Maybe it's the complete opposite. Let's say somebody's 90 years old. Oh, 0. No, that was not what I wanted. Yeah, it didn't change that much. A little bit. Okay. Nevertheless, let's delete that again. It got really late. I quite struggled actually. This was not simple. I haven't used the PET model before. I'm glad I did because it's quite revealing. It tells me a lot what I missed in the past. And I hope you enjoyed this tutorial. It's a bit all over the place, But yeah, I'm also testing, I'm also learning with you. But yeah, see you next time. And next time we look at the indoor comfort. That I'm also looking forward to, because the next step is then really look at the model, more on the model and how we can actually start to design things. I'm super excited. All right, see you next time.